I'm Eleni Ravanis. I'm a PhD student at the Hawaii Institute of Geophysics and Planetology.
On the 18th of February 2021, the NASA Perseverance rover successfully landed on the surface of Mars.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
One of the instruments on board this rover was the Mastcam-Z instrument. As part of my PhD and graduate research assistantship, I work as a student collaborator for this instrument. Although we tend to think of the Mastcam-Z instrument as a camera, it's actually a camera system, with two near identical cameras mounted about 2 meters above the Martian surface on the Perseverance rover's remote sensing mast. The difference between these cameras is their colour filters, which span slightly different wavelengths, allowing Mastcam-Z to take images in a wavelength range of 442 to 1017 nanometers. Taking images at a range of wavelengths, otherwise known as multispectral images, helps us to characterise the geology we see on Mars. The specific set of filters Mastcam-Z uses make it particularly effective at characterising iron oxides and hydrated minerals. The Mastcam-Z camera system also has the capability to zoom, hence the Z, and take videos, and even take images and videos in 3D. Awesome! What does it mean to be a student collaborator for the instrument? Well, recently I've been working as part of the downlink science support team for the Mastcam-Z. This means that we take the data coming back from the rover and produce products for initial science analysis by the wider Mars 2020 team. Let me show you one. This is a false colour image of a Mastcam-Z data product made by one of the science support team. This particular product is known as a decorrelation stretch. This decorrelation stretch uses principal components analysis to exaggerate changes in 3 different wavelengths within the spectrum of visible light. Those wavelengths are 630, 544 and 490 nanometers, also known as red, green and blue colours, the colours most human eyes are sensitive to. The visible colour differences could be due to changes in composition, mineralogy, texture, grain size, and are also affected by viewing geometry, but they give the Mars 2020 science team a first order idea of variation across a new scene. We make such decorrelation stretches as part of our standard set of quick look products, which the Mastcam-Z team present in the Mars 2020 science team meetings, which in this early stage of the mission occur every other day. In this particular image of a rock target known as Beaver Tail, you can clearly see a difference between the colour of the rock compared to the surrounding regolith. What questions are we trying to answer with the data the Perseverance rover collects? The Mars 2020 mission has 4 main science objectives, these being geology, study the rocks and landscape at the landing site to reveal the region's history; astrobiology, determine whether an area of interest was suitable for life and look for signs of ancient life itself; sample caching, find and collect promising samples of Mars rock and soil that could be brought back to Earth in the future; prepare for humans, test technologies that would help sustain human presence on Mars someday. The Mastcam-Z instrument, along with all the other amazing instruments on the rover, helps contribute to these overarching goals. What other research do we do as we work towards these goals? We also use other data from orbiting spacecraft at Mars, planetary analogue sites on Earth and modelling to help answer key questions about the rover's landing site, which is the Jezero crater. Jezero crater was once a lake filled with water, but the geological history embedded in the rocks is quite complex. For example, there is an olivine and carbonate bearing unit within Jezero crater, which may or may not be related to a regional olivine carbonate unit. Many different hypotheses have been suggested to account for its origin, such as lava flows, sand sea deposits, or ashfall from volcanic activity. An ash deposit will be a really valuable sampling target for the purposes of absolute age dating and geochronology when we return the collected samples to Earth. As part of my PhD, together with my supervisor, Dr. Sarah Fagents, I am going to be modelling such possible ashfall events. As a new PhD student in the Earth Sciences department, it's really exciting to work on such interesting research topics, and I can't wait to see what we discover.